Hey everybody, welcome back to Chapter 6, Section 6, Part 2. Here we're going to talk about proving whether a function is an inverse and then determining whether that inverse will be a function or not. So we're going to talk about something called the horizontal line test, and I'm going to relate that to what you've seen before, and that's the vertical line test. The vertical line test says this, that you can draw a function or a graph of a function, and you can draw horizontal lines through it. It should only pass through it once. If it passes through it twice, then it's not a function. So something like a circle graph would not be a function, or something like a sideways parabola would not be a function because there's two x values outputting to different y values. Um, you can have multiple y values associated with one x value, but not the other way around. So, um, since we're talking about inverses, that's opposite, we're going to talk about the horizontal line test. So you draw a horizontal line through a function or a graph, however you want to say it, and if it hits through it twice or more than once, um, it's not going to be a function when you do the inverse because the parabola is going to go sideways. Or, I don't know, if you have a circle and you turn that, you still have a circle. So, um, looking at this, uh, I can draw a horizontal line through that. So, yeah, it hits through more than once. So, it fails the horizontal line test. So, no, the inverse is not going to be a function. This one, it's going to be a sideways parabola, so it is not going to be a function. All right. The next one, same thing, slightly different looking parabola, but still a parabola, not a function. Okay. And the last one, well, draw a line through it, and it looks like it checks out. And I mean, there's a little dip here. It doesn't look like it dips a whole lot. If it dipped like that, then it would be no. So it's really hard to tell with this one. But I'm gonna go ahead and just say yes, that it doesn't look like it's dipping that far down. So we'll say yes, that's a function. Okay. Or the inverse will be a function. All right. And you see they had a similar looking one for their example. This is just a snapshot from the book right here. So, on this one, the first question I ask is determine whether inverse is a function. So, is this inverse going to be a function? Yes, it is, because when you turn it sideways, it'll pass the vertical line test. So, look, it passes the horizontal line test, okay? So, I'll just say yes to this. And then we're just going to calculate the inverse of it and then find the domain and range of the original and the inverse. So looking at the original, what's the domain and range? Well, it's all real numbers. Anything with an odd power is going to be all real numbers. You can see it moving freely up and down and left and right. So the inverse will just be the range answer is all real numbers, and then the domain answer is all real numbers. You'd just be flipping those answers. So I can already get that out of the way. So the next thing I need to do is calculate the inverse. So here I have it set up with the x and y being switched. So I'll minus 1, x minus 1 is equal to 2y to the third. So I can divide both things by 2, and you get 1/2 x minus 1/2 equals y to the third. So I will cube root everything. Alright, so you're going to get y equals, or instead of writing y equals, at this point you can write f to the negative 1 power of x equals the cube root of 1/2 x minus 1/2. So just kind of an important pattern to pick up on. The inverse is the opposite. So if you see the power of 3, your answer is gonna have the root of 3. If you have like the root of 4, your inverse is gonna be the power of 4. So that's what I mean by the opposite, not necessarily positive and negative here. Okay, but yeah. So we found the domain and range already, and we got the inverse. So we're done with example 1. So for number 2, is the inverse going to be a function? Draw a horizontal line through it anywhere. It'll pass it. When you reflect it across the line, y equals x, or invert it, it'll make like a half looking parabola, and those are always functions. So yes, the inverse will be a function. All right. Now calculate the inverse regardless of whether or not it's a function, and then we'll identify the domain and range. So what I'd like to do first again is look at the domain and range of the originals. All right. So the domains here start at 3, and then it goes to the right. So x is greater than or equal to 3. The range, well, where's this 3 at? That's when y equals 0, and then it goes up forever. Okay, so my new domain should be the range answer. So I'm going to say that it turns to y is greater than or equal to 0, except I won't use y, I'll use x. X is always for domain, and range is always y, so I'll say y is greater than or equal to 3 when I flip it, okay? Sorry for writing into the graph, I wrote too close to it. But let's do the inverse now. Alright, so the inverse here is going to be x equals 2 square root of y minus 3. And then remember, we'll keep that in mind where x is greater than or equal to 0, okay? So we will get rid of any number on the outside first, so I have to divide by 2 first. So that's 1/2 x, or x over 2, however you want to say it, equals the square root of y minus 3. So now I have to get rid of the square root, so I'll square both sides. And squaring both sides gives me x squared over 4, because x squared and then 2 squared. So x squared over 4 equals y minus 3. So now I can add 3 to the other side, and I get my final answer as f to the negative 1 of x equals, and I have x squared over 4 plus 3. And really, that's all there is to it, okay? We identified the domain and range, and then the function thing. And so, yeah, we're done, okay? Let's do example 3. Example 3, I didn't give you the graph beforehand. See, there's no graph here. But 3x to the 4th minus 2, why don't you type that in and pull up the picture of that graph? Okay, so here's the graph. It fails the vertical line test because it makes a parabola. Pretty much anything with an even power is going to fail that horizontal line test, okay? So the inverse will not be a function. That being said, we're still going to calculate the inverse of it. Let's talk about the domain and the range of this graph. The original domain is, well, what's happening with the x values. It's moving left and right freely. So the original domain is all real numbers. So again, that tells me whatever the range is on the new one, or on the old one. Wait, the range on the new one is all real numbers. That's what I'm trying to say. And so the range on the old one is going to be the new domain. So let's see the range on the old one. The lowest point here is -2. Makes sense. It shifted down 2. And then it's going up forever. So I'm going to say y is greater than or equal to -2. Alright? So that means my domain is going to be x is greater than or equal to -2. Okay? So the last thing to do here is to calculate the inverse of 3x to the fourth minus 2. So I'll write 3y to the fourth minus 2. So I can add 2 to both sides. I get x plus 2 equals 3y to the fourth. I can divide both sides by 3. And I'll just leave it as that fraction. So I get y to the fourth equals x plus 2 over 3. So get rid of the fourth power by fourth rooting. Anytime you have an even root, you put a plus or minus, unless it says like x is greater than or equal to 0 or less than or equal to 0. But if you go back and look at the original, it doesn't say anywhere about x being greater than or equal to 0 or less than it. So I'm going to write plus or minus the fourth root of x plus 2 over 3. And again, if you get a plus or minus function, technically what that means is, especially if you're using the graphing calculator, you're going to type in the positive fourth root of x plus 2 over 3, and then you'll do the negative fourth root of x plus 2 over 3, okay? So you have, from a certain point of view, two functions, okay? So at this point, let's look at the graph of this before I go any further. So here's the graph. The reason why I want to pull this up is because it's going to confirm what we said for the domain and range. Here we said the domain was going to be x is greater than or equal to -2, and then the y's were going to be all real numbers. So look, it starts at -2 in the x's, it's going right forever, so that's greater than. And then it's slowly going up and slowly going down, so y is in all real numbers, see? And so the last one I said, what are the inputs when the output is 241? So all you have to do here is plug in what's the fourth root of 241 plus 2 over 3, and what is the negative fourth root of 241 plus 2 over 3. That makes 243 over 3. 243 divided by 3 is 81. The fourth root of 81 is 3. So I'm going to get 3 and -3. And those will be my final two answers. And that's going to wrap it up for this video. So I hope this helped. I hope you feel like you understand inverses now. Thanks for watching. Bye.